So the first question, and again, anything that's on this class kit, you'll see again on your quiz on Monday, and no calculator. So if you use the calculator to help you out, remember that you will not have it on Monday. The very first thing you'll do on Monday is flip over your quiz, and on the back, you'll fill in your unit circle because that will help you with the end of these questions. So I would say start there. So if you haven't nailed down that unit circle, if you can't do it completely, then that's part of what you need to make sure that you review this weekend. Either, start with a blank one and fill it in as many times as you can until you know it well. So for 1 and 2, you don't need it. You're just converting, and it's either from degrees to radians or radians to degrees. Remember that the only sheer way to know is if it's got a degree symbol. It doesn't have to have pi to be in radians. So when you look at 1, it's got a degree symbol, which means it's degrees. When I go from degrees to radians, I multiply times pi over 180. So here I would multiply, and then 2 goes into both of these. I could start there. That would be 69, and this is 90. And then 3 goes into both of those, 23 and 30. The negative stays on that angle. We don't lose the negative just because we convert. So it'd be negative 23 pi over 30. For radians to degrees, we multiply theta times 180 over pi. So I would cancel the pi's. 25 and 180 are both divisible by 5. This would be 5 and 36, and it doesn't simplify any further, so I have to multiply straight across. 36 times 7 is 252, and it goes over 5. If you had actually divided, you could have kept it like that, but it has to have a degree symbol, so careful because a lot of you left that one off. If you had divided into it, then it would be 50.4. Which is exact. That's not rounded, so either of those answers are acceptable. You would not want to do it if it was something that was rounded. You're not rounding these. You want to keep them exact. Questions on either of those? Overall, pretty good. There were some silly mistakes made, so just be careful. Okay, then 3 was you're finding your coterminal angle. So in degrees, we add and subtract 360, but in radians, we add and subtract 2 pi. Most of you wrote that part right, but then be careful because some of you added 1/2 pi instead of 2 pi. So I would add 2 pi, and that becomes 50 pi over 25. So if I have to put this over 25, then it's 50 pi over 25. Some of you ended up adding pi over 25, so just be really careful, or 5 pi over 25. This would be 57 pi over 25. That would be your positive coterminal. And then 7 pi over 25 minus 2 pi, or 50 pi over 25, is negative 43 pi over 25. And that's your negative coterminal angle. Questions on that one? All right, then 4 had 2 parts. It said find the arc length and the area of the sector with the given angle and the radius. Keep answers in terms of pi. Again, no calculator here, so you won't be rounding these. The arc length is your S equals theta times the radius, or SOR. S stands for arc length. Theta is in radians, so that's one of the most important parts, is both of these must be in radians. And then R stands for the radius. So for both of them, I have to take theta that's given to you in degrees and convert it to radians. 230 times pi over 180. I would cross through the zeros, divide by 10, cross through the zeros, and I end up with 23 pi over 18. That's going to be theta in radians. So then my arc length is that 23 pi over 18, God bless you, times the radius, which is 9. That is 9 over 1. So I can simplify by putting 9 into 18 2 times. And I get 23 pi over 2. And I'd keep it like that. That's actually centimeters because it's length. But I'd keep it like that. You don't need to put it in decimal form. And then the area is 1/2 theta times r squared, or 1/2 r squared times theta. Order doesn't matter there. 1/2 theta is 23 pi over 18. And r squared would be 9 squared, which is 81. Some of you forgot to square the r, so be careful there. Again, if I want to put that whole number over 1, and then I can cancel in my numerators, denominators, whichever way I can simplify. I want to simplify to make these smaller numbers before the end. So 2 doesn't go into 23 or 81, but 18 and 81 are both divisible by 9. This would be 2 and 9. And then my numerators would get multiplied out. 23 times 9. 207, and the pi is there, over the denominators, 2 times 2 times 1, or 4. And in units, it'd be centimeters squared. Questions on those? Okay, then we get into finding the trig function using our unit circle. So if we've already filled out the unit circle, then this should be an easy thing to answer, relatively easy thing to answer. What you have to know is so if you fill out your unit circle, they're not going to all come directly from your unit circle. Most of them are going to be coterminals like these. I would also say it's to your benefit to add on the tangents. So you don't have to add them in every quadrant, but if you only wanted to add them on one, that's fine. Just know they would repeat. All your over 6 is your tangent is root 3 over 3. All your over 4s, it's 1. All your over 3s, it's root 3. You can even go as far as adding them on the quadrants too. 0 divided by 1 would be 0. 1 divided by 0 would be undefined, and that would repeat over here 0, and that would repeat down here undefined. So if you wanted to add them, you could. It's going to just take you extra time to add them all the way around, so keep in mind that you can also just use the all students take calculus to know the signs on those. So the first thing I want to do is look at the angle that's given, make sure it can't be simplified. 13 over 2 cannot. So I have two options. Find a coterminal by subtracting 2 pi, or convert that to a mixed number, which would be 6 and 1/2 pi. The rule on the whole numbers is that the evens are on the right. So 6 pi would be over here. 1/2 past it would put it at the 1/2 at the top, and the coordinate point there is 0, 1. The cosine is the x. The sine is the y. So if I want the sine, I'd grab the y there, which is just 1. Go to the next one, negative 7 pi over 3, okay? Maybe this is a time it's easy to do the coterminal. If not, that would be negative 2 and 1/3 pi. So because it's negative, I plot it as though it's positive. 2 again would be on the right, but 1/3 past it puts it at the 1/3 mark, which is now pi over 3. The negative means I flip it over the x-axis, I fold it like a hamburger, and my actual angle is 5 pi over 3. The cosine there is positive 1/2. Tan of 13 pi over 6 is 2 and 1/6 pi. So I'd go all around my circle to the 2 pi, or start at the even side, and I'd go 1/6 past it, which is the pi over 6, and we just said tangent there is root 3 over 3. Cosecant of 15 pi over 3, this is the first one that can get simplified. Cosecant would be actually of 5 pi. The odd whole numbers are on the left. My coordinate point there is negative 1, 0. Cosecant is the reciprocal of sine. If sine is 0, then the reciprocal would be 1 over 0, which is undefined. Secant of 27 over 4, put that into a mixed number. This is 6 and 3/4 pi. 6 is even, it goes to the right. 3/4 now goes past the halfway mark to the 3/4 in that quadrant. Secant's the reciprocal of cosine. If I flip negative root 2 over 2, I get negative 2 over root 2. And we're basically unrationalizing something that was already rationalized. And that gives me negative root 2. Cotangent of negative 19 pi over 3 would be negative 6 and 1/3 pi. So positive 6 and 1/3 was in the first quadrant. Fold it like a hamburger, goes to the fourth quadrant. It's an over 3, so my tangent there is root 3, and it would be negative. And then I'd flip it. It'd be 1 over root 3, negative 1 over root 3, which would be negative root 3 over 3. Be really careful with these. It's easy to make a mistake. All right, then the last ones, now we're reversing it. We're given the value and you're finding the angle where it occurs. To me, these are easier. There's no coterminal. You literally have to look at your unit circle and figure it out. The only thing that might be a little bit catchy is like secant. I have to do cosine first, but that's it. If I went around my unit circle and I filled in all my tangents and I'm looking for where it's going to be a positive 1, this would have been a negative 1, sorry. This would be negative 1, this would be positive 1, this would be negative 1. So I'd know that answer was at 3 pi over 4 and 7 pi over 4. All students take calculus. Tells you the tangent is negative in the second and the fourth. And 12, this would mean cosine of s equals 1/2. I need it to be positive and I need the x to be 1/2. That happens here and it happens here at pi over 3 and 5 pi over 3. Your quiz review is on Canvas, okay? It is, the solutions are also there. Number 6 is use a calculator. You won't be using a calculator. It kind of is, it actually totally says use a calculator, and then it says keep your answer in terms of pi. You'll be keeping your answer in terms of pi. You won't be using a calculator. So don't use a calculator on the entire review. And then again, make sure you know your blank unit circle, okay? You'll be filling that in